Okay, so we have figured out that we have 3 meta-stories, and so we want to solve part 1, so story number 1, which is 1 going to 2. And you'll notice that we don't really care about what's happening in the middle of the story. We just have the beginning point, the end point, and we don't care about anything in between. So we know that 1 to 2, that's going to be a beginning and after problem. And what's happening is that the block is moving, and as it's moving, friction is slowing it down. So friction is drinking away the energy of the little block. And so what we have here is a conservation of energy problem. So let's go ahead and set that up. So we're going to have that for 1 going to 2, this is going to be a conservation of energy problem. So I can go ahead and write down my conservation of energy equation. And I can look at the final energy. So the final energy, the little block is moving with speed vf. So 1/2 m vf squared. There's nothing else going on, so that's the final energy. The initial energy, the block is moving with speed v naught. So 1/2 m v naught squared plus w other. Okay, well, what forces are acting on this little guy? So let's go ahead and draw the forces that are acting on this little guy to make sure that we get all of our terms. So I've got weight, I've got the normal force, and I've got friction. And so you'll notice that weight is perpendicular to the displacement, so that does not work. The normal force is perpendicular to the displacement, so that does not work. But friction is in the opposite of the direction of the displacement, so that does negative work. So the work done by friction is actually going to be negative work. The force of friction is constant, and so the work is force times distance. And of course, the frictional force is just mu times the normal force, and the normal force is equal to the weight because the object has balanced forces along the y-axis. So if we plug all of this stuff in, we get that 1/2 m vf squared is equal to 1/2 m v naught squared minus mu mg times the distance. Well, what's the distance? The distance in my picture is actually L, so let me actually go ahead and write that as L here because that's what I call the distance in my picture. And you can see that the mass is canceled out, and I can multiply by 2, and I get that the final velocity squared is equal to v naught squared minus 2 mu g L, and that is my final answer. So now I know what is the final velocity of my little block right before it collides with the big block.